is artificial neural and it's working, we need to understand biological neuron. So that's how that process will go, and general properties of artificial neural network. However, I think let's see how we can finish with the properties of ANN, because this may be a spillover, but let's see. Okay, understand. So the outcome will be understand the working of biological neuron and artificial neuron, understand the historical developments of ANN and the general properties of ANN. Historical developments we are going to see, because this is important, how the process actually evolved, how neural network evolved. Of course, we are not going to go too much into its details, but some important highlights or milestones we are going to surely see. Okay. So to start with, let us see this. Okay, general applications. Now you know what is Tesla. Okay, the self-driving cars. Googles are also coming with the self-driving cars. Okay, in fact, on YouTube there is also videos about people driving or working with Tesla cars. Okay, and how it really works. There are a lot of videos also related to that. So here neural network or artificial intelligence as whole is used. Okay, neural network becomes a part in Tesla. Okay, now if you people are aware of this, Tesla has also filed a patent. Okay, and the name of the patent is Systems and Methods for Adapting a Neural Network on a Hardware Platform. Just see the title. Okay, Systems and Methods for Adapting a Neural Network on a Hardware Platform. Okay, so this is what is patent which is being and this is what is a set of neural networks which Tesla has also is being patenting. They have applied for their patent, and basically the basic of this particular patent or this particular methodology is that the constraint satisfaction is to be done by selecting the appropriate neural network. Like what I understood from this or what I read about it is, like if the car is driving and if there is some barrier, right, then in that case, how to tackle this particular problem of this particular barrier, some X type of barrier, then for that, which type of neural network has to be picked up and the activity has to be done. This is what this whole system is all about. So Tesla is being using AI in self-driving cars a lot. Okay, out of which neural networks is one part of it. Okay, deep neural networks, of course, is very much a part of it. Okay, then the below part, the below example, what you can see, a very, very popular, every day we people go through this. So selection of movies, not selection, suggesting of the movies or songs or what web series. Got it? So this Prime Video or Netflix also does this. Any other platforms also they do this. Now the question comes here that depending upon what you have seen earlier, okay, and the percentage of the content in that particular movie, depending on that, the neural network here will work and they will suggest you the next movie. Like, say, if you see this particular strip right now in front of you, this is my own strip. Right now, you could see the first two movies. I have been viewing romantic movies a lot. So the percentage of romantic movies or the percentage of romance in these the earlier movies which I watched, they were more. And so according to that, they suggested me the first two, which are romantic movies. Okay, but the third, in fact, the fourth one or the fifth one also, it contains some action. I don't know about Notting Hill, but Wolf Street, the Wolf of Wall Street and Harry Potter contains some type of action. Okay, I have been watching some 1 or 2 action movies. Of course, the romantic content there was high. Okay, so depending on that, they are selecting about how I viewed the earlier movies. So they are learning from the experience. Okay, learning from what I have seen, learning from their experience that this lady is watching these types of movies and out of which romantic content is more. So she might be liking romantic movies. So suggest her some romantic, so on and so forth. This happens in your YouTube also. If you have subscribed, or if you have, when you watch YouTube, it will suggest you some of the videos. Now, from where this suggestion comes? This suggestion comes from these type of selection criterias where deep neural networks work over here. Okay, then our own very, very famous Alexa. Okay, it utilizes neural networks and natural language processing. Now here, neural networks is basically used for natural language processing. And to be little more specific, it actually uses to convert a voice into text. Okay, and it's trying to make Alexa's voice as much as human as possible. Okay, that is what Alexa works on. This is just a base. Of course, it works on deep neural networks. Okay, but this is one part. If you have seen, the classic example for this, how natural language processing works. There's a YouTube clip of Daljit Dosanjh. Okay, and that's a fun this thing clip actually, which he is asking Alexa. He's playing with Alexa, and he's asking Alexa to play his song of some song. And the way he talks to Alexa and the way Alexa responds, you should watch that particular clip. It's fun, but now you watch that particular clip from this neural network angle. Now, what words, unless and until Daljit Dosanjh gives the correct name of that particular song, Alexa doesn't play that. Okay, so that's how it works. Right now, people are Alexa, who is actually been also headed in Indian by an Indian also. Right, they are trying to make it more human wise. Okay, because the way I am going to ask, the way you people will ask, okay, the way somebody else will ask is going to be different, though the content remains the same. So here neural network plays a major role. Okay. Now, coming to our main aspect. Now, what can you see over here? Okay. You see a picture. You all are with me, right? Okay. Somebody say yes or no?
Yes, ma'am.
Yes. Okay. Now, what can you see on your screen? You can see some animal. Okay. Now, just go back few years back and just see ki, you must be some person in your group. Somebody must be calling it as cat. Somebody is calling it as meow. Somebody would have recognized this particular animal as mouse. Right now, this is something which you started learning from your when you were very, very small, or you were in a phase where you started learning things. Now, during those times, how did your brain learn? Now we are trying to understand how your brain is learning. Okay, or how your brain started learning. Okay, now when first time you saw this animal, your parents, your mother, father, or whoever, they must have introduced you, okay, te bakti mau hai. Okay, some person would have, now that brain would have identified, okay, this particular animal with a short stature, with some 2 ears and 2 eyes like this, it is called as mau. Okay, but then somebody else would come say, okay, this is a meow. Okay, then slowly your brain started getting trained that, okay, this is a mau, this animal is mau, and it makes a noise of meow. Okay, then somebody would come and tell you, okay, it can be black in color, it can be white in color, and so on and so forth. But you will accept that it is black in color or white in color when you see some 2 or 3 examples. की अरे ब्लॅक कलरची माऊ पण असते, व्हाईट कलरची माऊ पण असते, आणि ते सगळेजण म्याव असं म्हणतात. ओके, देन स्लोली यू अडॅप्टेड, ओके, ही अशी चित्र आहे, दिस इज अ म्याव, दिस इज अ कॅट. Okay, we call it mau, we call it meow, whatever it is. Okay, then slowly your parents started introducing you to some other animal. Okay, hey, ek bubu hai. Okay, then you started understanding, okay, ह्याला कुत्रा म्हणतात. ओके, कुत्रा कसा भुभू करतो, so on and so forth. So what your brain is doing, your brain is learning, but it is learning from experience. Okay, somebody is training you, somebody is giving you that input. Okay, and your neurons have started working. Your neurons have the neurons in the brain have started working. Okay, they have started processing that information and they are giving you an output. So tomorrow, tomorrow in the sense when you were small, okay, at that time when somebody told you ki अरे हे काय आहे, जेव्हा तुम्हाला विचारलं गेलं असेल, then you would have said की अरे ही माऊ आहे, आणि मग माऊ कशी करते, तर म्याव करते. Right? But he process, this process took so much amount of information which you processed now. So your brain, what it is doing, it is taking the information, it is processing that information, and it is giving an output. So tomorrow, if you see a particular cat which is having, say, some different color and some spots, but still there is an uncertainty, there is an intolerance, there is imprecision of what you have learned earlier. But still you will be able to identify that this is a cat. I hope you are getting what I am saying. This is with reference, this statement I made with reference to my last session, okay, of soft computing, that there is a slight imprecision, there is a slight intolerance, but still your brain is processing in such a way that अरे ठीक आहे, ह्याच्यावर थोडे स्पॉट्स आहेत, थोडा कलर वेगळा आहे, पण ही म्याव आहे का, कारण की ती काय, तिचं व्हॉइस म्याव आहे आणि ती म्याव करते आणि तिचं डोळे असे आहेत आणि so on and so forth. So your brain took that information, processed it, and it gave the correct output. Okay. Now slowly when you started going to school, you started learning alphabets. Okay. When you started learning alphabets, तुम्हाला पहिल्याच दिवशी A किंवा B जमलं का, नाही. So what they said, okay, one slanting line, okay, one inclined line, the other inclined line, then a horizontal line makes an A. That, so through practice, now this practice is nothing but input data which is given to you. Then you started processing, okay, ashi slanting line, then the next slanting line makes it a A. Okay, similar way, you started interpreting ki are CAT, alphabet शिकल्यावर CAT means this is the cat, and this animal which is meow or whatever noise it makes, that is related to cat. So now whenever you see this particular animal, now this information will come from your brain and you will say that this is a cat. Okay, so that's how your brain is working. Okay, taking the information, processing it, and giving the output. Okay, but this is happening in your brain. Okay, nobody told you any equation about it. की म्यावचं फक्त मी एम असं असेल तरच त्याला कॅट म्हणतात, असं कोणी शिकवलं नाही. Okay, now let me ask you this question over here. Okay, now I'll give you a series of numbers. Okay, now you people can unmute and tell me what is the next number. Okay. Okay, now can somebody tell me the next number?
13.
13. Okay, anybody else? Okay, only one girl. Why? What about others? Is 13?
13.
13. Okay, some 2-3 students, they said 13. Okay, now if I say ki, okay, 13 is the correct answer, what will be the next? We'll take one more. Yeah, what will 21. Be the next?
21.
21.
Okay. It will be 21 actually. Yeah. Okay. So 31 who said, I assume that they wanted to say 21. Okay. Now, on what basis did you tell me that it will be 13 or it will be 21? Did I tell you anything about an equation? I did not say anything about it. I just gave you a series of number 1, 1, 2, 3, 5. What did your brain do? Your brain saw the numbers. Okay. It started processing, stating that, okay, the next number must be an addition of previous two numbers. And it gave me an output of 13 or 21. So in this, this is the way your brain is working. It's gathering the information from the previous numbers. It is processing that and it is giving the output, right? Now this, somebody might put it up in a numerical form, stating that n plus 1 is equal to n minus 1 plus n minus 2. So that's how this numerical equation will be there. This is nothing but your famous Fibonacci series. Okay, so the next number will be 34. The next number will be 34. 34 plus 21 will be the next number. Okay, so this is how your brain is working. So basically what is happening here is your brain is learning from the past experiences. Okay, it is storing that information and it is retrieving that information whenever it is required. Are you comfortable with this understanding? हे कळणं खूप गरजेचं आहे. Say yes or no. Okay, am I out or what?
Yes, ma'am. Yes.
Okay. So I'll give you one more example. Okay, please don't hate me for this, but because it is already 12 o'clock. But please try to understand. Okay. आता मी जर म्हटलं, I hope everybody understands Marathi. I will say pav bhaji. Now when I said this word pav bhaji, okay, your taste buds immediately started having that feeling of pav bhaji. Am I correct? Okay, I will assume this as yes. Okay, so what is happening in this process? Okay, your brain knows what pav bhaji is, because after eating pav bhaji for so many years, now it has understood that the input is one pav, this bhaji, the taste of bhaji will be this, like this. Okay, some imprecision here and there, it is fine. Okay, it will tolerate, and it is, your brain is storing that information, okay, about the taste, about the shape, size, color, etc. And when I make a statement, kyare pav bhaji, immediately the output is shown now in terms of your taste buds. Okay, so this is what is how your brain really learns. It is learning from the past experience. It is storing that data and it is utilizing that data. Intelligence. We are not talking about brilliance. We are talking about intelligence. So a neural network, what is a neural network now? It is designed to mimic this conjugate process followed by biological neurons in human brains. It is called as artificial neural network. So this is how when your brain works, learning, taking the data, storing that data, processing that data, and using it. So can it be possible to use this process, okay, mimic this process, okay, using our systems, using our computers, using our hardware, okay, so that you can use it for other applications? That is what is artificial neural network. Okay, so now if you want to design an artificial neural network which mimics this brain, the process of a brain, okay, I should first know what is a biological neuron, because the basis of neural network is biological neuron. So to understand this biological neuron, we go to the next slide, and here we talk about how a human brain really works. Okay, neuron in a human brain works. So human brain basically is a densely connected network of approximately 10 raised to 11 neurons. So each neuron, okay, and connected to an average of 10 raised to 4. It must be 14 or more than that. Okay, to others, means each neuron is connected to other neuron. And how many neurons like this you have? Approximately 10 raised to 11 neurons. So it means that it's very, very massive, very, very huge. Okay, that's what is your brain. Okay, and the fastest neuron switching times are to be known in order of 10 raised to minus 3 seconds. Now, what does this mean? This means say now wherever you are sitting, you just pinch yourself. Okay, now when I pinch myself, okay, a slight pinch, there will be, the pinch will be so small, that signal will be so small. It's nothing but ENTC people can understand. It's a signal. It's a signal processing. Okay, it's nothing but signal processing, in which when I pinch myself, the impulse, which is nothing but a signal, is reaching my brain. The brain is taking that input, okay, stating that there is a pinch type of thing which has happened. It will process that information. What is this processing? We will see. Okay, but it will process that information, stating that whether the signal is very strong or it is very weak. Now, what does weak and strong mean? म्हणजे तुमची pinch इतकी छोटी असेल, or that pinch must be so weak that the signal will die down there itself. It's not very prominent enough, and so probably you may not give any reaction to it. But if you tell your siblings, your sister or brother to pinch you, they might pinch you so hard. Okay, now when they pinch you so hard, the signal is so strong that it will go to the brain, and the brain will say, okay, the pinch is very hard. Now give a reaction. Okay, so the input which has gone there, it will get transformed into an impulse which will give you an output, and that output will be in terms of a reaction. So either तुम्ही तुमचा हात झटकाल or whatever, you will do something else. So that is how your brain is doing, and this all things are happening within 10 raised to minus 3 seconds. Within a span, it is happening. Okay, so what is this neuron? You can see this particular figure where my cursor is moving right now. This is a single neuron. Okay, this is another neuron, and these two neurons are connected to each other. Like this, you have 10 raised to 11. So what is this neuron? This neuron basically consists of dendrites. Okay, these dendrites, they bring the signals, okay, to the synapse, and this synapse has a neurotransmitter fluid. We'll see that in the next slide also. And from the synapse, through this neurotransmitter fluid, the signal will get transformed. Signal means, in biological terms, it is called as an impulse. In electronics or computer term, we call it as a signal. Okay, in neural network terms, we are going to call it as an input. Okay, that gets transformed, and all this will come to this middle part, which we call it as a nucleus. Here the processing will happen, and the reaction or the output will be given out through this axon. Okay, this axon will again go and meet the dendrite of another neuron, and there again this process will continue. Okay, this whole system is biological. So what is a neural network? Now this is what you are trying to mimic in artificial neural network. Okay, the name is very apt for it. Okay? It's a massively parallel distributed information processing system. We are going to see each part of this as we go ahead. Massive, I told you the meaning of massive now, 10 raised to 11 neurons. Okay, parallel distributed. It is distributed everywhere in the brain. Okay, and they are running parallelly. The processing is happening parallelly. Okay, so तुम्ही जेव्हा पिंच करता स्वतःला, किंवा जेव्हा तुम्हाला पावभाजी असं बोललं जातं, त्यावेळेला each neuron in your brain is working. It is not like only one single line of neuron is working. No, everything is working at the same time. Okay, so parallelly. Okay, distributed information processing. Information is processing over there. So when now you're pinching, immediately you're trying to, the neurons are sensing that, okay, now I have to give a reaction. Okay, or when I say pav bhaji, the brain is retrieving information. It's a color asa asto, it's a asto. Okay, you can immediately see pav bhaji in front of you, and your taste buds will immediately start working. Right? So that is what is information processing. That has certain performance characteristics, okay, resembling biological neural network of a human brain. Certain performance characteristics. Manje performance characteristics in terms of with reference to your inputs. So pav bhaji म्हणली की taste buds. Pinch म्हणलं की reaction in terms of maybe तुम्ही हात झटकाल, or you'll put water on that, or whatever it is, or you'll scold your siblings, so on and so forth. Certain performance. Okay, So what is a biological inspiration? So a nervous system is built up of relatively very simple units, the neurons. So this, what you can see here, the cursor where it is moving right now, this is a single neuron, a single neuron. Okay, so copying their behavior and functionality can be the solution for the neural network. Okay, means we are trying to mimic this. Okay, so what it really contains and how it really works, let's see that. Okay, now you can see these small things over here. These are called as dendrites. Okay, now what happens is, as soon as a input comes in, input in terms of say a pinch, or input in terms of any information, or visual input is there. So through your eye sensory organs, you see a pav bhaji or you see something else. Okay, so that is how the input is received through these dendrites. Then through these dendrites, it will come to a synapse. Now I'll show you a synapse over here. Well, it's not there over here. Okay, but you can see there's a synapse, a small dot-like structure between these dendrites and this small thin-like structure, which is called as an axon. Okay, so in this synapse which comes over here, you can see there are numerous amounts of dendrites. So signal is coming from everywhere. Okay, and it will get accumulated for a single dendrite, each single synapse, the information will get accumulated. At this synapse, you have something called as a neurotransmitter fluid. And what that neurotransmitter fluid does, the neurotransmitter fluid will process that signal, and it will see whether the signal is strong. Okay, if it is strong, if it is above the threshold value, it will go further. It will come over here in the nucleus. If no, it will die down here itself. Now, what is this threshold value? How to find this threshold value? It will transform that signal. So how to transform the signal, that we will see when we mimic it. Okay, we are going to have some activation functions, transfer functions. We'll see in the next slide. Okay, so here it will come, it will transform that signal, and all this signal from all these dendrites will come here to this nucleus. So it is something like the on the airport, you have the luggage counter, where all the luggage will come and collect at one moment. So here, in the similar way, the signals from all the dendrites, it will come and it will accumulate in the nucleus. Now, in the nucleus, what happens is, in the nucleus also there's a neurotransmitter fluid. Okay. Now here also, it's also called as a soma. Now what they do over here is, this neurotransmitter fluid again will see the signal, because now you have collective signal. Now you have net signal from here, signal from this dendrite, from this dendrite, from this dendrite also. So this is net signal, NET, net signal. Okay, and if this net signal again is above the threshold value, then this signal will be transformed and it will go to the next neuron through the axon. You can see this axon, which will carry the signals away. It will take it away to the next neuron. The next neuron, parallelly, it will be working in this similar fashion. Okay, so it is said that the input signals are combined in this soma, or we call it as a nucleus as well. Okay, and if the combination is strong, which is decided by the neurotransmitter fluid, then it is going to compare it with the threshold value. It is fired, means it goes ahead. If it is not according to the threshold value, it will not fire. It will die down there itself. Okay. Now this happens sometimes, many a times with us also. Kadi kadi aso hota, sometimes it happens with us. Ki when we are playing or when we are doing some work, right? We get hurt, but we don't understand that particular movement. Okay, or we don't understand it also. आणि मग नंतर आपण म्हणतो अरे हे काहीतरी लागलं होतं वाटतं मला. Now what is that? It is nothing but the signal was there. Okay, the input was there, but that signal was so weak that it came, probably it died down at the synapse, or the signal was like, okay, it came till the nucleus, but it was so weak, it was below the threshold value and did not fire at all. So तुम्हाला कधी समजलंच नाही की तुम्हाला काहीतरी लागलंय, right? That is how a particular biological neuron, it really works. So the dendrites will take in the inputs. Okay, it will come to synapse. At the synapse, you have a neurotransmitter fluid where the transformation of the signal is done. Then these signals will, all these signals together will come to the nucleus, where the neurotransmitter fluid again will compare it with the threshold value. If it is beyond, it will fire, and through axon it will take it forward. Okay, so if you really see and compare it with the artificial neuron, just check out, this is the same figure of a neuron. Okay, you have dendrites, you have a cell body, which is also called as a soma or a nucleus. You have an axon. Okay? So now we will mimic this with our artificial neuron. Okay, now which is the base of neural network. So say x0, x1, x2, these are nothing but your input. Okay, so dendrites are bringing in the inputs. Okay, so x0, x1, x2 will be your inputs. Okay, now they are having the signals, so they are having some weight, they are having some particular what weight itself, that's the correct word. Okay, so the weight when it comes to the synapse, right? So this is w0, w1, w2, these are the weights, that is the strongness of that particular input and the dendrite, or in this case mimicking x0, x1, x2. Now at the synapse, what it is happening, it is transforming it, it is having a net value, right? It is transforming it, so there will be a transformation over here. So what it will do here, it will net out, right? So w0, x0, okay, w1, x1, w2, x2, it will be net out at synapse. Okay, now this is the cell body, this is nothing but your soma. And soma madhe kai hota, what happens in soma or in the nucleus, all the dendrites will bring their signals, and in soma the signals will be combined, correct? So in this similar fashion, this input which is already passing through synapse, so w0, x0 will come here, w1, x1 will come here, w2, x2 will come here, and it will get combined. So summation of wi, xi, this will get combined. Okay, so cell body मध्ये सगळं combine झालं, it is combined in cell body. Cell body में सब कुछ combine हो गया, ठीक है? Plus one bias is added. Now why bias is added? It is to take care of some imprecision, some I'm not talking about anything about transformation right now. Okay, I'm talking about some imprecision, because sometimes some value needs to be added, okay, for making it much stronger. So that can be bias. Okay, what if you neglect the bias? Yes, it can happen. Bias can also be 0. Okay, but to be on a much safer side, always bias is always added. Now when we also said ki when all the signals come in soma, okay, they get again, it compares with the threshold, with the threshold value, and then if it is above the threshold value, then only it will fire. So to have this threshold value, you need to have something called as an activation function, because it might happen ki x0 is good, I mean it is above the threshold value, x1 or I'll correct myself, w0, x0, w1, x1 might be very good. Okay, the signals may be strong, but w2, x2 might not be strong. But in this case, when you are mimicking it, you cannot make this w2, x2 die down. So in that case, what will you do? You have to use activation functions, okay, which will activate your signals, which will transform your signals. So it's also called as a transfer function. Activate the functions, transfer the functions. Okay, so that, and which function, that depends upon the type of problem. We will see that a bit later. Okay, so activate the function, transfer the function which is above the threshold value, so that all the inputs will be considered, okay, and it will give you an output. So this is how you're going to mimic the working of a human brain, okay, through an artificial neuron. Okay, so this is what is an artificial neuron, which is mimicking your human brain. So what do you really have now? This is what is an artificial neuron. So you have inputs, x1, x2, x3. The weight, that is what you can say, the weight of this input, say for x1 it is w1, x2 it is w2, x3 it is w3. Okay, and a bias is added. This is the soma, this is a neuron in which the summation of this is done. The summation, how it is done, w1x1 plus w2x2 plus w3x3 plus bias is added. So summation is done. Okay, and it goes through a transfer function. This transfer function, one transfer function is shown over here. Okay, 1 upon 1 plus e raised to minus sum, that is your combination or net. Now this is one, I mean this is sigmoidal, this is for sigmoidal. You can have tan h is also there, then you have step function is also there, Gaussian function is also there. So you can use many of them depending upon the requirement of that particular problem. But this one is popular. So for this example, we'll consider this. Okay. So this will go through a transfer function and it will give you an output. This is what we call it as an artificial neuron. So linking of neurons is a systematic way forms an artificial neural network. Okay. So this is what is an architecture of a typical ANN. So you have, say now in this particular previous slide, what we saw was this is a single neuron. This is one neuron. Okay? But okay, you may have more amount of neurons also. Like in our brain, we have 10 raised to 11. Now we are mimicking it. So I will have say 3 inputs. You can have, of course, more of them. This is just one example. Okay, so you have 3 inputs. Okay, and you have something 2 outputs over here. Forget about this right now. Okay, and each of them are linked to this output. Okay, now in between this orange color, what you can see is these are called as hidden layers. Now you can have 1 hidden layer, you can have 2, 3, depends on the requirement of the problem. Okay, so each hidden layer also is having a number of neurons. Okay, now how many inputs, how many hidden neurons, how many outputs, it depends upon the problem, and there are some guidelines also for there are some guidelines also for these, which we will see as we go ahead with our course. Okay, now basically these hidden layers and these hidden neurons, they give you more degrees of freedom. They give you more degrees of freedom for computation. Okay, so that we will see when we go for the unit 2. Now what is happening over here, if you remember in the machine learning part, we have seen that you have an output, you have an input and you have an output also, and you are comparing that output with the actual output, the predicted output and the actual output, and your objective is to minimize the error. Okay, now the same thing we will be doing it here. So what is happening in this particular figure, you see this first input, it is connected to this first hidden layer. Okay, this first input is also connected to second hidden layer, second hidden neuron. Okay, the first input is also connected to the third one, also to the fourth one. In the similar fashion, the second input is connected to all of the neurons in the first hidden layer. This is the first hidden layer. This is the second hidden layer. Okay, in the similar fashion, third also. And if you go next, you can see that this first hidden neuron is connected to the first hidden neuron of the second layer. Similar way, this first hidden neuron of the first layer is also connected to the second neuron of the second hidden layer, and so on and so forth. Okay, going ahead, this first hidden neuron of second layer is connected to the first output. It is also connected to second output, and so on and so forth. So each of the neuron is connected to the next neuron in the hidden layer and connects to the output. So what is happening over here? Let's talk about this now. Okay, so each input, okay, you can see this blue color line and this black color arrow. So each input, say I will call this as x1. Okay, it will have some weight which will go to this first neuron of the first hidden layer. Okay, now when you have this weight, what is happening is there will be a net of information in this particular layer. So what net information you will have? X1, W1, X2, W2, okay, X1, X2, W3, plus the bias at this particular layer. Okay, so net information will come at this layer, and that net information will go through a transfer function as we stated over here. Okay, and that transfer function will give you, and that will happen for each of them. And so that with that transfer function, the answer which you get, that will be the output for this particular hidden neuron 1. Now for the next layer, this output of this hidden neuron is going to become input for this hidden neuron now. Subsequently, the output at this hidden neuron is going to be input for the output layer. Right? This is how the information is going to go further. Right? Here also, at this particular layer also, where my cursor is moving right now, here also you will have the net information plus bias going through a transfer function. The same thing is happening at this particular layer as well, where you will have the input, the net information going to the transfer function and giving out the output. So what is happening in this whole process? The information is getting collected, it is getting processed, and it is giving an output. It is happening at each layer, but it is happening in forward direction, as you can see with this blue color lines. So this is a classic example, or this is what we call it as feed forward. Okay. The information is moving from first layer to the second, second to the third, third to the fourth, and so on and so forth, and giving you an output. That is what is feed forward. Okay. Now there is a popular algorithm, backpropagation, that we will see as we go ahead to minimize the error. So basically, a neural network is suited to map any random input vector with the corresponding output vector. So you are connecting these inputs, this yellow color inputs, with the output, this blue color. Okay, but you are doing it, these are random inputs, you're connecting it to output with some algorithm in between. And this is nothing but what we call it as artificial neural network. Okay. Now this is called as an architecture of a typical ANN. Now what is this architecture? It's simple. You have the number of neurons in each layer will give you the architecture. So in this particular case, you have 3 inputs, 4 neurons in first hidden layer, 4 neurons in the second hidden layer, and you have 2 outputs. You can have 1, 2, 3, 4, how many outputs you want. Okay. So the architecture of this particular neural network is 3 as to 4 as to 4 as to 2. 3 inputs, second layer 4 neurons, first hidden neuron 4 neurons, second hidden layer 4 neurons, and output are 2 neurons. 3 as to 4 as to 4 as to 2. So that is what is a typical neural network. So it's 12:25. Shall I